In this video, I want to talk about what an angle is. So let's start by defining an angle. An angle is a figure formed by joining of two rays at a common endpoint. That common endpoint is called a vertex. So let me just sketch out an angle. These are supposed to be straight lines. So we have two straight lines meeting at a common endpoint, and this would give us our angle. This is what forms our angle. I'm going to be calling this angle theta. Theta is a Greek letter. It looks like kind of a zero with a line through the middle of it. Theta is a common name for an angle, kind of like we use x for a variable. But we could use any variable or any name for this angle that we wanted to. So again, this point right here where these two rays meet, this is called the vertex. Now, before we go sticking some numbers on these things and figuring out how to draw them, I want to standardize my angles. I need to know I want a way to look at them all off of the same point or the same line. And so what I'm going to do is I'm going to look at an angle in standard form. And so a standard position angle starts on the positive x-axis. So we have our x-axis, we have our y-axis. So this side right here would be what's called the initial side. And then wherever the angle takes us to, that is what is called the terminal side. So we have our initial side down here. And we have our terminal side up here. And so what that means when our angle is in the standard position, that means that the vertex is always at the origin, our vertex being at the origin. So here, this angle is very close to being in the standard position, but notice if I were to have drawn the x-axis on there, just sitting above, the initial side is just sitting above that x-axis, so not quite in the standard position. Also, I would point out that notice I always have the arrow on that angle because it is important to know which way the angle is taking me. We don't have to travel in this counterclockwise direction. We'll see what causes us to travel in two different directions. So it is important to note that angles do have a direction to them. So let's draw a couple angles. Here are some angles I think we probably already know. For one, we know a 90-degree angle. So let's put a 90-degree angle into the standard position. That means we have our vertex at the origin. The initial side is on the positive x-axis, and the terminal side would be on the positive y-axis, so going straight up here, and that would be a 90-degree angle. That would be the angle taking us from the x to the y-axis, like that. And we indicate those 90-degree angles with this little square in the corner. That is a 90-degree angle, right angle. I think we also know 180 degrees. 180 degrees would just be two 90s, and that would take us all the way around to the negative x-axis. So we're starting at the positive, we're getting around to the negative x-axis. And this is what's called a straight angle. We look at 270 degrees, that is just three 90-degree angles. So we're going to travel from the positive x-axis to the y, to the negative x, down to the negative y. And so our angle has passed through three whole quadrants here. And then finally, I think we know what a 360-degree angle is. 360 degrees being a full circle, that takes us a full rotation. So if we were to start at our positive x-axis, we've gone all the way back around until we hit that positive x-axis. So it's useful to know these four positions, and really there's another position we kind of already know. We know a 0-degree angle. 0 degrees just means we haven't traveled at all. So if I were to start at the positive x-axis, I would end at the positive x-axis. Not that I moved anywhere, just that I stayed exactly where I was. So notice that we actually get the same terminal side with both 0 and 360. Those are what are called coterminal angles. And coterminal angles are angles that share the same terminal side. So we see that 0 and 360 degrees are coterminal angles because we've gone that full rotation. Anytime we add or subtract 360 degrees to an angle, that gets us to a coterminal angle. So for instance, if I wanted a coterminal angle to 90 degrees, coterminal, I'd take 360, add it, and that would give me 450 degrees. I could add 360 again. That would give me 810 degrees. And so we can do that over and over again, but we could have also gone backwards by 360. So far we've just been looking at what happens as we travel in a counterclockwise direction, but we can actually travel in this counterclockwise direction. So if I had wanted to go, say, a negative 90 degrees, let's see what that would look like. Well, negative 90, I know that 90 takes me from the positive x to the positive y. I go that right angle. Negative would just mean I'm traveling backwards. So rather than traveling up, I'd be traveling down. And so my negative 90 would put me right here. If I were to travel negative 180, same idea, I'm traveling backwards, so rather than going in a counterclockwise direction, I'm going in a clockwise direction. And that would put me at the negative x-axis, starting at the positive x-axis. Well, notice negative 90 is in the same position as 270, which means those have to be coterminal angles. Negative 180 is in the same position as 180. That means they have to be coterminal angles. So how did I get that? Well, I could have taken 360 and subtracted from the original angle. So 270 minus 360 is a negative 90. 180 minus 360 is a negative 180. So coterminal angles, to get to a coterminal angle, we can add and subtract 360. So we're going to use all these ideas, we're going to put it all together now, and we're going to sketch the terminal side for some angles, some given angles. So let me type out the instructions. Sketch the terminal side for the given angle. Let's start with an angle of 30 degrees. Well, we have 4 basic positions that we know right away. 5 if we include the 0, but 0, 360 is the same position really. So 4 basic positions we can start with. If we think about 30 degrees, 30 is obviously between 0 and 390 degrees. So that puts it in the first quadrant. If we think about 30, 30 is much closer to 0 than it is to 90. In fact, we know exactly what fraction along the way it is. 30 is 1/3 of the way to 90. So when I go to draw 30 degrees, I'm going to draw it 1/3 of the way to my my positive y-axis. So that would be 30 degrees. I'm doing a sketch. I'm not asking for a great deal of precision here. We're not going to break out our compasses and protractors and draw these things with extreme accuracy, but we do want to have it proportionally correct. So I wouldn't want to show that 30 degrees was, say, up here, because that's not close to being a third of the way through. We want to have it proportionally correct. Let's take another angle. Let's take 290 degrees. Well, if I compare this to my 4 positions, my 4 known positions, 290, greater than 90, greater than 180, greater than 270, but less than 360. So I know it's in that third quadrant. It's going to be somewhere, in the fourth quadrant. It's going to be somewhere between the 270 and the 360, somewhere in this fourth quadrant. And I know that 290 is 20 degrees more than 270. And if I think about each of these quadrants comprising 90 degrees, if I'm 20 degrees past the y-axis, that means I'm 2/9 of the way past the y-axis. So that would put my angle approximately here. Again, not super precise, but we've gone 270 degrees around and then 20 more. I've shown that it's much closer to the y-axis than it is to the x-axis. There would be my terminal side for the 290 degrees. Let's look at a negative angle this time. Let's take an angle of negative, let's do 135 degrees. Well, if we had a positive 135 degrees, comparing to our 4 positions, 135 is between 90 and 180, so that would put it somewhere in that second quadrant, past the positive y-axis, but less than the negative x. And 135, well, 135 is 45 more than 90, but 45 less than 180, so it'd actually be in this dead center of the second quadrant. However, it was a negative 135, so that means rather than traveling in the counterclockwise direction, I'm going to be traveling in the clockwise direction. Puts it just down here in the third quadrant. We would have traveled negative 90 to get to here, and then we're going halfway through the quadrant, and so it's splitting that quadrant in half. That would be our angle, the negative 135. Let's take an angle of 465, writing different than I'm saying, an angle of positive 465 degrees. Well, now if I compare this to my known positions, more than 98, 180, 270, 360, it's more than 360, meaning it's greater than a full rotation. So I could continue adding 90 and I could figure out all those positions again in their coterminal angles, but it's easier just to concentrate on this one angle here. Let's find a coterminal angle for this angle right here. So to do that, I'm going to subtract 360 degrees. When I do that, I get 105 degrees. So 465, what that would be is it's a full rotation, full 360 degrees plus 105 degrees more. Well, that 105 now is between angles that I know. 105 is between 90 and 180. So I know that that 105 will be in that second quadrant, and it's just 15 degrees past the y-axis, so it's very, very close to that y-axis. So that would be my terminal side. If I were to have actually sketched out the angle here, I'd have to show that it goes a full rotation, and then it goes 105 more. So we can see how drawing the angle on these is going to get really messy, and that's why I just asked for that terminal side, because I don't care how many rotations it's making necessarily. You know, there are times that I would care. If I'm looking at, say, like a plane circling an airport, it absolutely matters how many rotations I've made, because if I've made 100 rotations, I might start running out of gas while I'm waiting to land. But there's a lot of times I only care about the final position. So, if I've made a couple rotations around the airport, or if I've made a couple laps waiting for a lane to become open, I care about the angle that I am at to the runway right now, because that's what I need to land. So we care about both things. But if I'm going to do this drawing, I'm not going to show all those rotations necessarily. It just gets real messy. I want to show where the side actually ends up. Let's do another example with an even a bigger angle. So let's take 1,592 degrees. So that's much greater than 360. I could sit here and just subtract 360 a whole lot of times, but that's going to take me some time. So what I'm going to do, I'm going to be a little bit more efficient about it. I want to figure out the coterminal angle again. That's my goal. And to abbreviate angle, I'm going to just draw the little angle symbol there. To do this, what I'm going to do is I'm going to take my calculator, I'm going to take this number, I'm going to divide it by 360. So if we take the 592, divide by 360, we get 4.42, blah, blah, blah. All right, so we get approximately 4.4. Now, that's not giving me my coterminal angle. That's not what this is. These are two different things right now. What that is giving me is the number of full rotations. So what I can do, rather than subtracting 360 a lot of times, and we can see how this would get quite cumbersome for really huge angles, what this gives me is the number of full rotations I must subtract off. I have 4 full rotations at 360 degrees each. So what that means is if I were to take 360, multiply it by 4, that gives me 1,440 degrees worth of rotation. So again, what I did is I took these two numbers right here and I multiplied. That's giving me how much those 4 full rotations accounts for. Now, I need an angle of 1592. So what I'm going to do is I'm going to subtract off those 4 full rotations, and that gives me 152. And so when I take off those 4 full rotations, my coterminal angle is this 152 degrees. So that is between the y-axis and the x-axis. It's going to be closer to the 180 because it's 62 degrees off the y-axis. It's only 28 off the x-axis, so it's going to be somewhere in here, a little bit closer to the x. And so again, I'm just drawing the terminal side. I don't care to see that I have 4 full rotations there. That's getting really messy. And then some. I just want to see where it ends up. But I do know that there are 4 full rotations there. If we have negative angles, same exact idea. So let's take, negative 2,592 degrees. Well, obviously, we've gone backwards a lot of times, a lot of rotations, and then we've gone a little bit further. So what I'm going to do is I'm going to take this and divide by 360. So let's take 2, and I don't need to put the negative on it. I just care about the number of rotations, so it doesn't matter if we have a positive or negative. If I were to divide these, I get approximately 7.2. Again, treating as a positive. So starting with this initial angle, I know I have 7 full rotations in the negative direction, and then I have a little bit more in the negative direction. So let me take the 7 times 360. That is 2,520 degrees worth of rotations that we've accounted for in those 7 rotations. So 7 full rotations accounts for 2,520 degrees, which would leave me, if I were to subtract these two things, that would leave me a negative 72 degrees. So what this tells me is I've gone 7 full rotations, a lot of circles early in the negative direction, a lot of circles backwards in the negative direction. I'm ended up 72 degrees past where I started. So if I were to sketch that, that would have to be down here in the fourth quadrant, negative 72 degrees. And so that would be my terminal side. Now, some people really dislike working with negatives, and we could have worked around that. We could have said, well, hey, if there's negative 7 rotations, or if there's 7 full negative rotations and then a little bit left, well, why don't I just treat it as 8 full rotations in the negative direction? We'll see what we end up with. So if I take 360 times 8, that gives me 2,880 degrees. I'm going to subtract off the negative amount that we had to start with. So I'm going to take that number, subtract 2,592. When I do that, I get 288 degrees. Well, if we look at this angle, we've gone past the 270. We've gone past by approximately 18 degrees. That looks pretty good. It might even should be a little bit closer to the y-axis, but approximately correct. So we have two coterminal angles here, the negative version and the positive version. Notice in all of these problems I've been using degrees. I've constantly written this degree symbol there. That is important to write that degree symbol there, because if I leave that off, that angle is no longer a degree angle. That is a radian measurement if we don't have a degree symbol there. And so I'm going to talk about radians in my next video.